Hi, I am Junius Santhan from IIT Kanpur. Today I will be presenting evaluating neural word embeddings for Sanskrit. Why word embeddings for Sanskrit? It's basic ingredient in NLP downstream task, and mostly it's experimented and analyzed for resource-rich language such as English. And availability of potential unlabeled data in near future due to digitalization efforts going. What are word embeddings? Basically, word is projected in a vector space in such a way that two meaningful words or related words are in close vicinity, and words which are not related, they are far away in that vector space. There are two types of embeddings, static and contextualized. For example, let's take word chakri. So in this context, the meaning of chakri is potter, but if we take same word in another context, so its meaning becomes Lord Krishna. So this is contextualization. Word embeddings further we can divide into three subcategories: token level, subword level, and character level. This categorization is based on the inputs that we consider. So in this work we have considered total 6 word embeddings, 4 for static category and 2 for contextualized category. They are namely, in 2013 word to wake got proposed, which is based on distributional semantics. In 2014 the global statistics were used in the GLOVE approach, but both the approach suffer from outer vocabulary problem. So in fast text, the subword modeling was considered. And further, in same line, character level embedding got proposed in 2016 using the character level language modeling. And in contextualized domain, so first ELMO was proposed, which uses the LSTM encoder, and in 2020 the BERT contextualized model proposed, and which uses transformer architecture. So let me talk briefly about these different approaches. Word to wake basically uses distributional semantics. That means word is known by the company it keeps, so it uses the sliding window approach, and it predicts the words which are in this near vicinity. Now you can see that this architecture that word to wake is using. GLOVE uses global co-occurrence matrix, and they have this different training objective in contrast to the word to wake approach. Word to wake and GLOVE both suffer from out of vocabulary problem. To mitigate this, we used sentence space as a solution. So instead of applying these approaches on words directly, we apply it on segmented versions. To mitigate the out of vocabulary problem, FastText uses subword modeling, which is very similar to the word to wake, but additionally they use subword modeling in their architecture. And CAR-LM uses the character level language modeling, and for feature engineering they use CNNs to obtain representation for the complete words. In contextualized family, ELMO uses LSTM architecture, and it is based on bidirectional language modeling. And Albert is the light version of BERT, and this is also contextualized model, but it uses a transformer architecture, and it uses mask language modeling objective for training. To evaluate word embeddings, two different approaches are proposed in literature, namely intrinsic evaluation and extrinsic evaluation. In this work, we will be focusing on intrinsic evaluation. So basically it is defined as the class of methods to measure the quality of vector representation without evaluating them on downstream tasks. So in this work we have considered 4 tasks, namely relatedness task, synonym detection, analogy prediction, and categorization task. These query inventories are readily available for resource-rich languages but not for Sanskrit. So one of the contribution in this work is that we have developed the inventories to facilitate this intrinsic evaluation. We use Amarkosha, Sanskrit WordNet, Sanskrit Heritage Reader to build these inventories. Now let me discuss briefly about these intrinsic evaluation task. First one is relatedness. It's not synonym. Basically, semantically related words can co-occur in the same context and share any semantic relationships such as meronymy and antonymy. For example, Paricharika and Vaitya are semantically related, but Pradhyapaka and Karkati both are not related. So annotators have given first pair as a 2.5 score and next pair is 0.5. So this score is out of 3. So these two are very much relevant and these two are not related. To create inventory for any new language, general approach is translate the English data into the new language and ask annotator to give relatedness score. But challenge that we face that there are many words which cannot be naturally translated into Sanskrit. For example, automobile, cushion, and autograph. So we used the systematic organization of Amarkosha to obviate this problem. In Amarkosha, synonyms are categorized into synset and related words are into vargas. So we modified this task into classification problem. So there are 3 classes that we consider: word pairs from the same synset, word pairs from same varga but not same synset, word pairs from the different vargas. So here we create a data set. So test set contains the 9000 pairs and development set contains the 4500 pairs, and the evaluation metric is the macro F score. So we have identified the thresholds. So if the similarity score is above 0.6, then it is the first class. If it is the 0.4, above 0.4, then the second class, and like that. So this threshold we have identified using the development set in this classification problem. Next, synonym detection. It is multiple choice selection task. The goal is to find the synonym of a given target word from 4 synonym candidates. For example, in this case, Surya is a target word, and out of 4 options, Aditya is the correct synonym that our approach supposed to find. The word which has highest cosine similarity is the prediction from that word embedding, and we use the accuracy metric for evaluation. We have developed 3000 questions for this task. Basically, we exploit the synset and varga division of Amarkosha to achieve this. Next one is analogy prediction task. For example, if kapi is similar to kapibhyam, then in the same sense, yati is similar to the which word. So there are 2 categories: syntactic analogy and semantic analogy. For syntactic, we have used Sanskrit Heritage Reader, And for semantic analogies, we use Amarkosha, Ramayana and Mahabharata. You can see that there are different relationships for syntactic: declension, conjugation, absolutive and infinitive. And for semantic, husband, wife, son, father, daughter, father, charioteer, warrior, defeated, victorious, and son, mother. So this has been taken from Amarkosha, Ramayana and Mahabharata. We developed 10,000 syntactic and 6,500 semantic questions using the above resources, and here the accuracy is the evaluation metric. Finally, in categorization, the task is group nominal sets of concepts into natural categories. It's unsupervised clustering task where word representations are clustered into the n clusters. And evaluation metric is purity. So again, there is two classification, semantic level and syntactic. So for semantic, 15 classes based on Amarkosha's Vaisesika ontology categorization, and the 45 classes from morphological tag containing 25 elements in each. Finally, we evaluated all the word representations on these 4 tasks. We find that ELMA outperforms all the word embeddings, and sentence piece helps to overcome out of vocabulary problem. If you compare between word to wake and glove, so global statistics is helping slightly better. But we find that character level language modeling and Albert do not perform that well, and one of the possible reason may be that data is insufficient to train this model. We perform the error analysis. For analogy prediction task, we find that if there is a modification in the root, then the model fails to predict the correct answer. But if there is no modification in the root, then mostly it predicts correctly. And for relatedness and similarity task, we observe that for the out of vocabulary words, the performance is low. In this section, we perform qualitative inspection for rare words. We divide the words into 2 categories: vocabulary words and out of vocabulary words. In each category, we select 3 words, and we calculate the top ranking words from the vocabulary based on cosine similarity for each representation. So we find that for these representations, so the candidates are inclined toward orthographic similarity and lexical meaning is captured well. But for Carolyn and Albert, we do not see that the candidates are competent and lexically similar. And similar trend we also find in out of vocabulary. In this section, we perform qualitative inspection of contextualized embeddings. We take the Chakri word in 6 different contexts where there are 2 categories, and when we obtain its vector representation in 2-dimensional using PCA, then we find that there are 2 clusters that we can observe here. So the context which direct towards the potter, meaning they are clustered together, and the context which is directing toward the Lord Krishna, they are clustered together. In summary, our contributions are these word embeddings perform better for syntactic and poor for the semantic level task, and sentence piece helps to improve glove and word to wake. And out of all the representation, Elmo performed well, and we publicly release code and datasets available to facilitate the research in this direction. Future work contain evaluation of multilingual pre-trained models, evaluation with a context-sensitive task, and to propose novel approach for Sanskrit. Thank you very much for your attention. Any questions or comment?